Okay. Hi, Kaustubh. How are you?
Yes, fine, good.
Okay, great. So, can you please introduce yourself?
Yes, my name is Kaustubh Surendra Aras. I am from Kolhapur, Maharashtra. I have completed my bachelor's from PS Modern College of Engineering, Pune. I have completed my diploma in mechanical engineering, and I have done my schooling from Vivek English Medium School.
Okay. So, whenever you give introduction, tell the previous thing first. So, first you start with schooling, then diploma, then degree. Okay.
Okay, sir.
So,
Okay,
what essentially happens is now essentially happens is that I essentially plans out a chronology. Okay.
okay, sir.
And obviously, I should be forgetting about your schooling and giving more attention toward your degree and all.
Bachelor. Okay, okay,
Okay, yeah.
sir.
So do it that way. And after in near end, preferably add something related to, because see, your introduction is too small. Okay,
Yes.
what did you say? You just say, where are you from? Your school, that kind of panel don't care. Your diploma, that again they don't care. And your college,
Okay.
which again they really don't care. Okay. So it was very
Sir,
short. So elongate
uh,
it.
what can I add, sir? Like extracurricular activities and hobbies like
Not
this. So should I?
really, not really. You can add maybe your internship, if any, or your final year project, something like that.
Okay, sir.
Okay, you must be having something of those. Okay,
Yes, yes.
okay, so you can add that. And this is a little risky move, but you can also add what are your favorite subjects or something like that at the end of your tell me about yourself. I don't
Okay,
recommend this to everyone. I had done that, but it's risky. Okay, I mean you are just inviting them to attack on you like as soon as your introduction ends. Okay?
I thought, sir, they may ask me to tell the subject.
They
Therefore, I
will
have
ask you,
given.
don't worry. What I had done was I just wanted to cut out all the bullshit and them directly start on technical, okay? Because
Okay.
that's what my strong area was. Okay, Kaustubh. So, what are your subjects that you have command on?
Like, sir, first is strength of materials, basic thermodynamics, fluid mechanics, and machine design, sir.
Okay, so here is a question for you. So, we have a beaker here, okay? It is uh, okay. We have two different vessels, okay, and both of them are completely filled, okay, 100% filled, and they are not open to air, they are filled completely, okay. In one I am in one I am hitting it from below, okay.
Okay.
So how will be the heat transfer be occurring inside this particular vessel? It is, you can consider this is a metal type of vessel, okay. You can ignore whatever is happening inside this surface, and I am mostly caring about what happens inside the water or whatever that fluid is. So how will be the heating happen here?
Okay, sir. Basically, it is completely filled, so there is no space. The heating, the process inside the vessel will be completely. The heat transfer will be completely by convection, sir.
Okay.
And
That
also conduct, yes, convection and conduction also in like the bottom layer.
okay. So you are saying here will be convection and conduction. So which one will
Yes,
be dominant?
conduction will be, sir, basically at bottom layer only. And convection will be more dominant, sir, over here.
Okay. So
Means like free convection.
pre-convection. Okay. So I mean, how will be the flow here occur? So will the particle be going up due to heating or
Yes,
something like that?
because as we start to heat, density will decrease of the particle which are at the surface. So due to density difference, they will rise and they will get replaced by the particles which are at the top above sides.
Okay. And what will happen? Will there be any currents or something like that?
Uh, like the currents in the sense.
In the case, flow currents that I'm talking about, rotational, something like that. I mean, if this is going up, then something will come down and that will heat up again, right?
Yes, sir, yes, sir.
And how will that happen then? You are right, actually. What you are saying is right. So, you know,
Yes,
there will
the
be something
fluid
like
will,
flow
yes, yes,
current,
yes,
something like that. So
circulation, yes,
circulation, yes,
circulation
that's
rate,
what
yes,
I'm.
yes, sir.
Okay, this is correct. You know, in the bottom, very bottom, there will be conduction and then we'll have
Yes, sir.
convection. Correct.
Convection hole.
Now, same scenario, but I am hitting it from top.
Sir, in the second case, only the conduction will take place because earlier our particles are the topper side, like top side, and they will get heated up. Their density will decrease, but they will not travel downwards. They will remain upper side only, and they will
Hmm.
only the heat transfer below will take due to the conduction. Like the heat transfer will be due to the molecular molecular diffusion, sir.
Okay, that is correct. So, which giving I am giving out same amount of heat in both the cases
Okay.
for a same amount of time delta t. What will be the which one will have a higher temperature rise, or which one will rise the temperature faster or something like that?
In case of faster, sir, first case will be faster compared to this one because here
Hmm.
both the conduction and convection are taking place simultaneously, and along with it, mixing of fluid also takes place. So due to that, heat will transfer faster in first case compared to second one, sir.
Correct. So it will that is true. It will transfer faster. What do you think about temperature of the system?
Like sir, overall temperature or at the opposite surfaces like that, so something.
Overall temperature.
Overall temperature. Sir, it will be like greater in B, sir,
Mm-hmm.
like second case.
Okay. And how do
Because
you what do you mean by greater here exactly?
I mean, compared to first one, like we are here, the particles are not moving.
Right. You're right. Go ahead.
We can imagine like solid, like how we imagine in solids, sir. That type of mechanism we can see over here. So a temperature will be more in the case of second case, sir.
Okay. That is
Because
correct.
the heat will not dissipate faster like in first case. So more storage may occur, sir, of heat due to not moving. So therefore, the temperature rise will be more, sir, in second case.
Okay. So which one will get higher amount of energy overall? Which one initially it was at some lower energy level, then you heated
Yes,
it
sir.
up, it reached to some higher energy level. So which one will be at higher energy level and why? Respect to the other one.
Sir, first one will be at higher energy levels because the most of the molecules are coming in contact with our heat supply, rather
Correct.
than second case that more molecules are not in the contact with the heat supply, sir. So the energy levels of first will be higher, sir, compared to second one.
So total energy of case A will be higher than total
Yes,
energy
sir.
of case B,
Yes,
right?
sir. Compared to B. Yes, sir.
But you know, you are giving out same amount of heat for a same amount
Uh,
of time.
yes, sir.
Then what will be the total heat transfer that happened here? That will be Q into delta T.
Yes, sir.
What will be total heat transfer occurred here? That will be again Q
Q
into
into
delta
delta
T.
T. Yes,
Then
yes.
so
I
this
think,
raises question on two of your answers. Okay, number one, the higher temperature one
yes, sir.
that you said B will have a higher temperature, and second, the higher energy one. You again said A will have higher energy. What can you comment?
Uh, Sorry, sir. I'm not able to think.
Okay, that's okay. So did was your statement saying that both will have sorry, A will have a higher energy level? Was that correct?
No, sir, because the energies we are supplying in the both the cases are same over here, sir.
Yes. So if we are supplying same energy,
Then they
that
will
means
have,
obviously same
yes,
will both will gain same amount of energy.
yes, sir.
So what is exactly the difference here?
exactly depends, sir. In first case, every molecule, like we compare the molecules. Like what I thought is was like that every molecule comes in contact with our like heat source, so they may they may be at higher energy levels. Like here, not every
That is,
molecules are.
I understood that. So your answer was incorrect. We corrected it, right? Now,
Yes, yes,
given
sir.
we supplied Q delta T heat to both of them, both should have at same energy level, right?
Yes, sir.
Okay. Now, if I ask you to calculate the mass average of its temperature, which one will be having a higher mass average of its temperature?
Sir,
Or
what
wait, wait,
exactly is?
wait. This will have some Tmax, right? Maximum
Yes, sir.
temperature.
Yes,
And
sir.
this will have some Tmax.
Yes, sir.
Which one will have a higher Tmax or both will be same? Tmax here is essentially temperature inside the whole, the domain and the maximum temperature of any particular molecule or something like that.
Sir, Tmax, I think it will be more in B side,
Mhm.
sir.
Okay. And where will be this Tmax situated?
Near the surface, sir.
So which surface?
Like top surface, top
Top surface.
surface.
Yes, that is correct. So Tmax
Yes,
in B will be higher
high.
and it will
Yes,
be a
sir.
top surface. What
Yes, sir.
what can you comment about A? Can you comment something about A?
Uh, like can't say the exact position, sir, because the molecules are like in the circulation form.
Correct.
So, sir, it might be difficult to find like exact location of Tmax, sir. So
Hmm.
overall average temperature will be like can't say uniform, sir, but it is difficult to find Tmax over here
That's a
because
correct
the
answer.
because molecules are not continuously in contact with the surface. They are just leaving the surface.
Correct. So just before I ask you to find out mass average of its temperature, how do you calculate mass average of any quantity?
Like, sir, what's the mass average
What do you think?
exactly? I
What is
didn't
mass average?
like by going like overall average temperature or like we will
Yes,
consider overall
that
system
is overall average temperature.
average temperature of the
Correct.
system
But you have to
like
weight it with something.
per
Whenever
unit
you say
mass, sir.
average temperature,
Okay,
anything average, you need to weight it against something. Like sometimes we weight it using volume, sometimes we weight it using mass, right?
okay, sir.
Or you didn't get this particular thing.
No, sir, I didn't know about that mass like mass average.
Okay. Okay, fine. So you need to find out average temperature. Which one will have
Okay,
a higher average temperature?
like as a heat transfer is same, so average like temperature must be same, so in the both the cases.
Is that correct? And
Yes, sir.
how do we calculate average temperature? In this case, if I ask you to calculate average temperature, how will you calculate average temperature?
Sir,
You just said that both will have same average temperature. So you came up to that conclusion somehow.
like sir, I based on that
Your conclusion is
same
correct. You are
heat
right.
transfer is same in the both the cases, and like they are closed system. We are
Yes, you are right.
so
Your answer is
they
right.
will have. Yes,
Your
sir.
answer is right. Now, how would you find average temperature?
So do we have any like temperature sensing device or over there,
Yes,
or
you can
we
have
can use,
whatever
sir?
you want. Yeah, you can have whatever you want. You can use
So over
mathematics or anything. I'm asking you mathematically. You don't need to imply that exactly, but
okay.
mathematically, how would you calculate it?
So we may measure the initial temperature and the final temperature. That would not be helpful.
Why do you need initial temperature in case you already have final temperature?
Yes, sir.
So you are giving good answers. That's why even I am loving interviewing you. Okay.
Thank you,
So
sir.
yeah, please go ahead. How will you? I'm asking you mathematically. You don't need to think, भाई मैं measure कैसे करूंगा, हल molecule का temperature
Okay,
कैसे
sir. Okay.
ढूंढूंगा. You don't need to care about that. Tell me mathematically.
Just sir, over the certain time intervals,
Mm-hmm.
we can calculate for up to delta t. So we can calculate the various readings,
Mm.
and after certain time,
But let's say here temperature could be, let's say, 100.
yes,
Here
sir,
it
different.
could be
Yes, yes.
90. It could be 80. But now I want an average temperature.
Average temperature.
What is average meaning exactly?
Average meaning sir means like we consider like it is varying inside, but when we see up to system, so it gives a fixed quantity. So it is varying inside, but we can like somehow
So,
come to
so,
a conclusion like that
so
is the average
let's say you
temperature.
have three numbers, you have 90, 80, 100. How will you calculate average of them?
Just add and divide it by 3, sir.
Correct, correct. Now, can you do something like that here?
Yes, that was like, at certain time intervals or a certain points in the system. If the system is our big or like a very big or a little bit small, but
That is okay.
like
You don't need
based
to.
on in the system at various locations and various time intervals, we can calculate the temperature
Hmm.
at particular time intervals and some particular locations. And from that, sir, we can judge the average temperature of our overall system.
Okay. So will this work out? You are right, but you are missing one factor here.
Time. Okay, sir.
Time, you don't need to care about time.
No,
Leave
yes.
it.
So we can after the heat transfer is finished, at that particular time we can calculate the locations.
No.
Mm,
Think.
that's not done.
Okay, I can give you a clue maybe. Okay, I'll give you a clue. Okay. So let's say you have a pipe here. Okay.
Okay, sir.
Okay, and you are given some velocity profile, something like this. It could be
Yes, sir.
anything. Okay.
Yes.
Now I'm asking you to find out what is my average velocity through this pipe. How do you calculate average velocity?
Like sir, in this case, we must equate our that velocity with the ideal case, sir.
Mm-hmm.
Means in the velocity profile, we can here the discharge will be uniform. So like we can assume the uniform profile for the mean velocity,
Hmm.
and we can equate it with the our real velocity profiles.
You will
And
equate
from
it with
that,
velocity profile or what?
no, so like discharge equation, our equation for like mass flow rate.
Correct.
We can equate the real mass flow rate with the by considering the ideal mass flow rate, means mass flow rate of ideal velocity profile and mass flow rate of real velocity profile. We can compare the both and we can
Correct.
find the average velocity in this case.
Now can you tell this exactly mathematically?
Uh, like sir,
Let's say
in the
V of R is my velocity profile here given.
okay,
This is distance R. Can you give me that mathematically?
yes sir, first we can assume the ideal like uniform flow, sir.
Hmm.
Like velocity is constant over there, so in that case it will be rho a into u, rho a u, the mass
Ignore
flow rate.
rho. Ignore rho.
Rho constant, okay sir, a into u.
Correct.
And in our case we can calculate the this we must calculate first find the velocity profile, equation of velocity profile,
You have given
and
that V as a function of R.
v as a
You
function
already
of
have it.
r into dA, sir, the elemental area.
Correct.
which will be varying from 0 to r, sir.
Correct. And you will
Yes, sir.
integrate this,
Then
right?
yes, I will integrate this
Huh.
over this.
So essentially you are saying that my velocity will be, average velocity will be something like this, right?
Yes, sir.
Is this area average of velocity? Essentially you are weighting, you are giving the weight of area to this velocity. So this
Okay, sir.
is actually area average of velocity.
Okay, sir.
Are you getting it?
Yes, sir.
Huh. Now can you think of something like that here?
Like, sir, mass heat
Again, you don't need to
inter.
care about how will we measure and all. Okay, those are
Okay, okay,
secondary
sir.
topic. Yeah, I'm asking you mathematically.
Sir, like we can assume an average temperature like like on in the heat flow equation, like amount of heat supplied, like c delta T average. No, this is not average. Sorry, sir, I'm not able to think.
What do you think about this?
Temperature profile into, yes,
dm is actually mass.
mass, yes, sir.
Okay, so this is actually a mass average of temperature.
Okay, sir.
Essentially, this is nothing but internal energy. Okay, if I multiplied
Okay,
it with CV,
okay, sir.
this is nothing but internal energy. But
Yes,
given
sir.
my CV is constant here.
So yes, I was thinking in this space like CC constant, and just I was like confused about the T. We can we can directly take like T average or delta T. So that was a bit confused.
That is correct, but in case there are some, so this particular expression will be valid for everywhere.
Okay, sir.
Okay, so this is more
I will
like an
remember.
average temperature, mass average of a temperature. So essentially, I am weighting it with mass, and then
Okay,
I'm
sir.
taking its average. Okay,
Okay, sir.
weight
Yes.
here means not the time wala weight, the how much
Okay.
weightage you are assigning it to
Yes,
it.
yes,
Okay,
yes,
yeah.
yes.
So this is essentially time. Sorry, temperature mass average of the temperature. Okay. Now here is a
So wait, like
uh,
charging is not.
take. Anyway, here was anyway last question for you.
Yes, sir. Sir, I am not able to switch on camera.
Okay, just a minute. Let me. हाँ कर लो.
Yes.
Hmm.
Is it visible, sir?
हाँ, it is. So now this was my case A and case B that I told. Okay, discuss
Yes.
about
Okay.
something like this. Can you draw velocity profile along its height? Sorry, temperature profile along its height. This is my temperature. This is along the height. Okay,
Height is on y-axis, sir.
height is on y-axis. Yes, I mean it is
Means like
just looking like that. Yeah, you need to understand.
okay, okay, sir. Sir, in first case, it would be like a decreasing one from a top to like we as we consider the edge at the top, like initially at top side. In
This is
second
height.
case,
Huh?
sir.
Huh. So
Uh,
what will be top if I start from here? Should I go to right or left?
no, sir. I was talking about second case, sir.
Okay, second case. I'll start here now.
It would be decreasing, but on temperature will be decreased. So, sir, like on towards left, sir, it would be.
Okay, so something like this you are talking about.
Yes, yes,
Okay,
yes, sir.
and what about here?
In that case, actually. So, sir, like it is increasing. It will be like increasing from bottom to top side, sir.
Okay, so
And
I
it
am
would be
starting
higher
from here.
at
Should I go to left or right?
right side, sir.
So something like this.
Yes, sir. It will be rising. Oh, no, no, sir. Sorry, sir. Sorry, sir. it will be more at bottom sides, and it will be lesser as we go away from H, like away from the base.
So
It
you are
will be
saying
on left
something
side.
like this.
Yes, sir. Yes, sir.
Is that correct? Both I'm talking about.
Yes, I think exact temperature profiles curve.
That is okay. I'm not asking you exact, but at least
Like
I want some.
increasingly, yes, yes, sir, yes, sir. Intuitively, I can give you this answer, sir.
Okay, bottom one is correct, not the top one.
Okay, sir.
You only said that there will be a lot of mixing happening, right?
Oh, yes, sir, yes, sir, yes,
What
sir. That
exactly is the meaning of mixing?
yes, sir, sorry, sir. That like hotter molecules will be replaced by cold ones, so they will settle on the topper side, sir. So the temperature at top side will be more, sir, as compared to bottom one. Like
No.
more accumulation will be occur, sir.
And then you know what will happen? The molecule who are at the bottom, they will get heated up and they will go again up.
Yes, sir.
So due to
That's also.
circulation, overall
Yes,
the
sir.
temperature will be constant throughout the domain.
So can we assume it as constant temperature process, sir?
Kind of, yes. Because there is
Okay,
will be
sir.
so much circulation that temperature will be
Yes,
overall constant.
uniform.
Obviously,
Yes, uniform
uniform.
temp, like
Obviously, there
uniformly
will be
over.
some gradient toward the lower side, but it
Yes,
won't be
yes, sir. Yes,
much.
sir.
It
Okay,
won't be
sir.
much. That is the point because you know everything is moving around here.
Yes, sir.
Okay, so it will be some. So now that
Yes.
is correct. So yeah. So I'll end your interview now. So Kaustubh, very well done actually. That was an
Thank you,
amazing
sir.
interview to have. So few good things about you, you are able to convey.
Okay, sir.
You are able to state what you wish. And one thing that I liked is that you are clearly mentioning that this is my assumption, and using this assumption, this is the answer I am able to draw. For example,
Okay,
at the
sir.
end, you said ki, matlab, this is my intuition says, not mathematical, but intuition says. I mean, that's very good clarity to have that you know exactly how to approach a problem. So that's amazing, actually.
Okay, sir.
So, I mean, at this stage, I really don't have anything to suggest you. Just keep on. एंड एक और अच्छी बात, तुम डर नहीं रहे थे, ठीक है, बीच में थोड़ा कंफ्यूज हो जाते हो, दैट इज ओके, ओके,
Yes, sir.
पॉइंट इज यू आर स्टिल एबल टू कम टू फाइनल प्रॉब्लम, फाइनल सॉल्यूशन, सो योर ट्रैक वाज ऑल राइट, सो दैट्स अमेजिंग एक्चुअली,
Okay,
कीप
sir.
इट अप। कब है इंटरव्यू आपका?
सर 27 मई को है।
चलो
एंड
बढ़िया, सो
ऑल्सो ये एनपीसीआईएल का भी हुआ है सर, शॉर्टलिस्ट
हाँ हाँ,
ऑन 8 जून।
एनपीसीएल का कहाँ पर है?
8 जून इस कायगा में है सर।
कहेगा में, चलो बढ़िया, घूम
कायगा।
के आना, और क्या, मस्त
नो सर, ये
ट्रॉपिकल
पास में है
रहेगा।
सर, वो
अरे हाँ,
घर के
तुम्हारे
पास
लिए
में है।
पास में है, हाँ, तुम्हारे लिए पास में,
यस
राइट
सर,
राइट।
लाइक कर्नाटका के नियर ही पड़ता है मेरा गांव,
हाँ
चंदगड
हाँ,
ऑल्सो।
कोल्हापुर में, राइट। सो दैट्स अमेजिंग एक्चुअली, सो कीप इट अप, यू आर इन गुड ट्रैक। सो
थैंक यू
इसरो का
सर।
भी कुछ हुआ है?
नो सर, आई हैवंट अटेम्प्टेड द
ओके,
एग्जाम।
ठीक, चलो, बट ठीक है, you already have two options in your hand, so that's good.
यस सर।
चलो, so with that, let's conclude your interview.